Good morning, students. After the completion of the chapter that is nitrogen containing compound, that is amine and diazonium salt, next we switch over to another chapter that is known as polymer. So in this class today we discuss about what is monomer, polymer, polymerization, types of polymer, types of polymerization, and some useful polymer, method of preparation and uses. So let us start from the introduction part, that is polymer. So what is a polymer? When the large number of simple repeating unit repeat itself to form a single giant unit, then the small simple repeating unit is known as monomer and the single giant unit is known as polymer. And the mode of formation, the method of formation of polymer is known as polymerization. For example, if we select ethylene CH2 double bond CH2, ethylene, large number of ethylene, n number of ethylene molecule undergoes polymerization, then it will form a single giant unit. That means this unit repeat for a long time period to form a single giant unit. Its name is ethylene, its name is polyethylene or polyethylene. Then it is known as monomer, it is known as polymer. The simple single repeating unit is known as monomer and the single giant unit is formed known as polymer, and the process of formation of polymer is known as polymerization. Next, we discuss the classification of polymer. Next is classification of polymer. Next, we discuss classification of polymers. Polymers are classified into different way on the basis upon different property, different character. Let us discuss one by one. Point 1. On the basis of availability, on the basis of origin, it is 3 types. One is natural polymer, one is semi-synthetic polymer, and one is synthetic polymer. Point 1 is on the basis of origin. On the basis of origin, polymers classified into 3. One is natural polymer, one is semi-synthetic polymer, and one is synthetic polymer. The polymers which occur naturally, that is known as natural polymer. God-given polymer is known as a natural polymer. For example, protein, wool, rubber, etc. Semi-synthetic polymer. The natural polymer is chemically advanced, chemically modified polymer is known as semi-synthetic polymer. That is for example, nitrocellulose, cellulose acetate, etc. Then synthetic polymer, that is a man-made polymer made in the industry, that is known as synthetic polymer. Example, ethylene, polyethylene, example is polythene, PVC, Teflon, etc. These are the man-made polymer. So on the basis of origin, again I repeat, the polymer are classified into natural polymer, semi-synthetic polymer and synthetic polymer. Next, on the basis of structure, on the basis of nature of a chain, polymer classified into three types. One is straight chain polymer, one is branch chain polymer, and one is three-dimensional network cross-linked polymer. Mark that. We discuss one by one. That is, on the basis of structure, on the basis of structure or nature of a chain, it is classified into linear chain polymer. Next, branched chain polymer. Next, three-dimensional network cross-linked polymer. So discuss one by one. Linear chain polymer. That means a polymer which is formed in which monomer molecules are joined linearly in a straight chain, as a result of which the intermolecular forces of attraction is maximum. That is known as linear chain polymer. Due to strongest force of attraction, they have high melting point, high density, high tensile strength. For example, nylon, terylene. Next is branch chain polymer. The polymer which is formed in such a way that they form branch chain along with the linear main chain, then it is known as branched chain polymer. That means due to branching, the intermolecular forces of attraction are weaker than the linear main chain. So they have a low melting point, low density and low tensile strength. For example, glycogen, amylopectin, etc. Next one is three-dimensional network cross-linked polymer. That means the polymer formed in which the monomer are joined linearly in such a way that along with the linear main chain, they form three-dimensional network cross-linked polymer. That's why they have strongest intermolecular forces of attraction. So for example, bakelite, that is phenol formaldehyde resin, urea formaldehyde resin, bakelite, urea formaldehyde resin, etc. I repeat again. On the basis of structure, on the nature of the chain, polymers are classified into three types: linear main chain, linear chain polymer, branch chain polymer, and three-dimensional network cross-linked polymer. Next, we discuss another one is there, that is on the basis of repeating unit. If the repeating unit are same, that means monomer same, known as homopolymer. If repeating unit are differ, then known as copolymer. Next we discuss on the basis of repeating unit. On the basis of repeating unit, two types. One is homopolymer and one is copolymer. Homo means same. That means when the same repeating unit same monomers are joined together to form a polymer, then it is known as homopolymer. For example, polythene. When ethylene, large number of ethylene molecules join together to form polythene. Vinyl chloride, large number of vinyl chloride join together to form a polymer known as polyvinyl chloride. That means, example, polythene, polyvinyl chloride, Teflon, etc. On the other hand, when the more than two different group are there, different monomer is there, with different functional group is there, then join together to form a polymer known as copolymer. For example, nylon 6,6, nylon 6,10. It is on the basis of repeating unit. That means on the basis of repeating unit, again polymer are of two types. One is a homopolymer and one is copolymer. Next, on the basis of force, magnitude of force of attraction, polymers are classified into four types. One is elastomer, second is fiber, third is thermosetting, and fourth is thermoplastic. Elastomer, fiber, thermoplastic, and thermosetting. Mark that. On the basis of magnitude of forces of attraction, on the basis of magnitude of forces of attraction, that means elastomer, next fibers, thermoplastic, last one is thermosetting. Mark that. So, on the basis of forces of attraction, polymers are classified into elastomers, fibers, thermoplastic, and thermosetting. The first one is elastomer. The polymer formed in such a way that the magnitude of forces of attraction among the monomer unit is very weak. Then that type of polymer is known as elastomer. Due to weak forces of attraction, they have low melting point, then low tensile strength, easily stretchable. For example, nylon, rubber, next one is fibers. The polymer formed in such a way that the magnitude of forces of attraction among the polymeric unit, among the monomer unit is strongest one. As a result of, they have high melting point, high density. So that type of polymer is known as fibers. For example, Dacron. Next one is thermoplastic. The polymer which is formed in such a way that the magnitude of forces of attraction lies in between that of elastomer and fibers, then that type of polymer is known as thermoplastic. The magnitude of force neither so weak nor so strong. For example, polythene, PVC, polyvinyl chloride, etc. Next one is, fourth one is thermosetting. Thermo means heat. That means these are the polymer formed upon heating, three-dimensional network polymer. Upon heating they melt, flow and transfer into any mold to form any design, and after cooling it gives the desired product. Once cooled, it gives the desired product. Next onwards, never melt. This is known as thermosetting polymer. That is, urea formaldehyde resin, for example, bakelite, melamine formaldehyde resin, urea formaldehyde resin, etc. Again I repeat, on the basis of magnitude of forces of attraction, polymers are of four types. One is elastomer, fibers, thermoplastic and thermosetting. Next one is on the mode of polymerization. Next method is on the mode of polymerization. Polymers are of two types. One is addition polymer, one is condensation polymer. Next one is on the basis of mode of polymerization. On the basis of mode of polymerization, addition polymer, condensation polymer. On the basis of mode of polymerization, polymer are two. One is addition polymer, one is condensation. What is addition polymer? When the monomer unit are similar monomer unit are joined together without the elimination of simple molecule like H2O, HCl, and NH3, then that type of polymer is known as addition polymer. For example, polythene, polyvinyl chloride, Teflon. On the other hand, if the same or different monomer unit joined together in such a way that undergoes condensation polymerization in such a way that there is the elimination of simple molecule like H2O, HCl, NH3, etc. Then that type of polymerization polymer is known as condensation polymerization. For example, Terylene or Dacron, nylon 610, nylon 66, etc. On the basis of mode of polymerization, polymer are two. One is addition polymer. Simple R, there is no elimination of water molecule. Here, different molecules are there, different monomer are joined together with the elimination of single molecule, undergoes condensation polymerization to form condensed polymer. Next, on the basis of degradability, on the basis of biodegradability, polymers are classified into two types. One is biodegradable polymer, one is non-degradable polymer. Mark that. Next one is on the basis of degradability. Polymers are of two types. One is biodegradable polymer. One is non-degradable polymer. First is biodegradable polymer. Some polymers are there which are decomposed by the biologically for a certain time period, as a result of which they decompose and hence not affect to the environment or not create environmental pollution. That is known as biodegradable polymer. For example, PH, BV, nylon 2, for example, nylon 2, nylon 6, etc. These are examples of biodegradable, decomposed by biologically, not create any environmental pollution. Next one is non-degradable polymer. All the man-made polymers are there. They are not decomposed biologically for a time period and hence produce environmental pollution. So they are known as non-degradable polymer. For example, polythene, polyvinyl chloride, Teflon, etc. So on the basis of degradability, again it is of two types. One is biodegradable polymer, it is non-biodegradable polymer. These are the simple idea or classification of polymer. Next we switch over to classification of polymerization. Polymerization are classified into two types. One is addition polymerization, one is condensation polymerization. Next we discuss classification of polymerization. Polymerization is of two types. One is known as addition polymerization. One is known as condensation polymerization. First we will discuss about addition polymerization. I repeat again. The polymer formed by joining the simple monomer unit in such a way that there is no elimination of simple molecule, that is water. For example, vinyl chloride. N molecule of vinyl chloride, when undergoes a polymerization to form polyvinyl chloride, it is known as polyvinyl chloride, PVC. There is no elimination of simple molecule is there. Then it is known as addition polymerization. Next we will discuss condensation polymerization. That means the polymer form different monomer unit joined together undergoes condensation polymerization in such a way that there is the elimination of simple molecule like H2O, HCl, etc. Then that type of polymerization is known as condensation polymerization. For example, nylon 6,6, nylon 6,10, terylene or Dacron, etc. Let us discuss one example. Nylon 6,6. Here hexamethylene diamine and adipic acid. Mark that. When n number of hexamethylene diamine combine with adipic acid, mark that. Hexamethylene, its name is hexamethylene diamine, its name is adipic acid, undergoes polymerization. Its name is hexamethylene diamine, its name is adipic acid, undergoes polymerization. Mark that. What happened here? H, OH, here H, here OH, remove, resulting the formation of NH, CH2 whole 6, NH, CO, CH2 whole 4 CO N. Mark that. It is known as nylon 6,6. Why it is known as 6,6? Because the first unit possesses 6 carbon, the second unit possesses 4, 5, 6 carbon. That's why it is known as nylon 6,6. So in this case, when they undergoes condensation, release of water, here H, one OH, that is the release of simple molecule like water. That's why it is known as condensation polymerization. So on the more, that means polymerization again classified into two types. That is, one is addition polymerization and one is condensation polymerization. Next, we discuss some common useful polymer examples under the basis of addition polymerization and condensation polymerization.